So StorageOS is a software-defined storage system, and we are certified for Red Hat, and we work very well with OpenShift. We're designed for Kubernetes and orchestrated workloads, but effectively what we're trying to do here is we're taking stateful workloads that you would traditionally not run in Kubernetes and allowing you to run those stateful workloads in Kubernetes. So we're software defined, we're actually just a single container. That means we're platform agnostic, we can run anywhere your container can run. We scale out and operate with Kubernetes, within your Kubernetes project, and we do all of the standard data services like replication and compression and security like encryption. And this allows you to apply production workloads with HA and failover to things like your databases, your message buses, your things like instrumentation, perhaps Kafka, Prometheus, those sort of things. So internally, we're just a container, and within this one single container, we have our control plane and a data plane. The control plane manages the state of the environment, and the data plane manages all of the virtual volumes and the data services that run within that service. So as we said, it is just a container. We deploy with we have a standard operator similar to the Rook concept using the operator SDK. We can also run with daemon sets or a Helm chart, but an operator kind of gives you that one-stop shop automation for all the future upgrades and maintainability of the cluster. And once that container is deployed, we have an embedded etcd KV which manages which keeps the state of the volumes and the state of the cluster health. And we also establish a gossip protocol across all of the nodes so that we can maintain, we can get an idea of the node's health and the general cluster health. Within there, we also have an API endpoint, and that API endpoint is used, as a standard RESTful API, but also for our CLI, and also the plugins and integrations. So things like the Docker plugin, the Kubernetes native drivers. So we're mainlined into the Kubernetes from 1.7 and up. As well as the new container storage interface, which is this new interface which Kubernetes is using for the newer versions of Kubernetes as a standardized interface for implementing container storage. We virtualize the different disks that are available on the nodes. So this can be things like physical disks in bare metal, or virtual disks in VMs, or cloud instances like EBS volumes, for example. And obviously, we prefer to use local disk, but we can happily use any disk which is visible on the host. So we can use, storage from, say, an existing storage array if that's what you have today. And we take all of those disks and we create a pool of storage that now spans all of the nodes. What this means is you can now create a StorageOS volume out of that pool and put your stateful workload on it, say Kubernetes, and say a Postgres database in this example. And what's really cool is that the volumes that we create within the pool exist within a global volume namespace. So when you've created that volume, it's immediately accessible on all the nodes. You no longer have to worry about attach and detach times, which, as Jared mentioned previously, is really the bane of a lot of high availability problems. So now your orchestrator can effectively move your stateful workloads to any other nodes in the cluster, and it continues to access the disk just as if it was a local volume. We do synchronous replication between the nodes, and we do synchronous because typically most of the people that are using StorageOS are putting workloads like databases or message buses, which need a very high consistency. They need to be able to survive node reboots or loss of power or that kind of thing. And effectively what we do is we make sure that the data is persisted to a user-definable number of replicas for a volume before we acknowledge that data has been written to the application. One thing which we do is we compress all of the all of the data that's going out over the network, whether that's for access or for replication. And this dramatically reduces the network bandwidth because most data sets are actually very compressible. And once we have the replication in place, if you do lose a node, we will automatically promote one of the replicas to the new primary and deploy a new replica, and Kubernetes can transparently just restart the data set on one of the other nodes. All the volumes are thinly provisioned, so we only use the amount of space on the back end that you actually put into the volume. So for example, you could have 10 gig worth of disks, but create a 1 terabyte volume, and you just use the backend. Disk as you fill the volume. One of the advantages of this is that you can provision, for example, cloud storage as you go, because you can extend the pool by just adding additional disks into the pool dynamically, and we will automatically distribute the data across the different nodes in the pool. Typically, we would be deployed in a hyperconverged type topology where every node contributes storage to the pool, but also runs applications that consume storage. But what we find is that beyond a certain size, many organizations prefer to have a hybrid topology where some of the nodes are contributing storage to the pool and other nodes are just used for running applications. And this could be for commercial reasons, for example, when you have say storage optimized nodes in the cloud, or perhaps it could be because there are technical or organizational, operational type issues that drive that. We also wrap all of this up with an automated policy engine, which takes the labels that you apply to your pods or your volumes and wraps that with placement and policy decisions. So for example, you could say, if I have a production database label applied, I will automatically put it on the fastest SSD pool, I will run 2 replicas, and I will apply this set of encryption keys. And what this allows you to do is kind of have the ability to self-provision and use all of the declarative capabilities of Kubernetes, but still maintain a bit of a safety net, and whereby you can make sure that your volumes get the right levels of data retention policies or performance policies applied. From a developer point of view, all of the volumes are typically managed via the Kubernetes persistent volume claim, like Jared just described. You can obviously use the StorageOS CLI too, or the API. We transparently integrate into all of the Kubernetes namespaces and our back and ABAC capabilities, so you can kind of segregate volumes, users, and groups into different namespaces for perhaps segregating projects or different tenants in a cloud environment, for example. And what this really looks like is we register a storage class. This is very similar to the storage class that Jared just showed. So effectively, we're saying here, we're creating a storage class, we're calling it fast. We set a couple of parameters and say use the StorageOS provisioner. And what this allows is a standard user to issue a claim to the storage class. The claim looks something like that, where you say, use the fast storage class, and I want 5 gigs worth of storage, and you get your pod. You get your claim attached to your pod, and now you have your 5 gig of storage. And the declarative and composable nature of this really shouldn't be underestimated, right? So the ability to abstract away the storage requirements, just like you abstract away, for example, CPU, memory, network port requirements for your applications, means you can now pick up that YAML file for your app and run it anywhere you want. From a management point of view, there's a easy to use CLI. There's a GUI which provides you the capabilities of providing additional views and configuration for StorageOS. And we also expose a whole ton of instrumentation via Prometheus. So the CLI should be very familiar if you use, for example, Docker CLIs or kubectl. And yes, I'm going to call it kubectl because that's the right word for it. We also have a GUI that shows you things like namespaces, users, nodes, volumes, rule sets. And the Prometheus API exposes all of the metrics on a per volume, per node basis, which we have a couple of handy Grafana and Telegraph templates which you can use to kind of visualize what's going on there. And that is it. So a bit impromptu, but I hope that was helpful. And again, we'll be around if anybody has any questions. Thanks, guys.
I have a question from online.
Oh, cool.
And that question is, how is StorageOS better than BGFS? That's the question. Even though BGFS is ported over to Kubernetes.
Right. So I don't have an in-depth knowledge of BGFS, but BGFS is a distributed file system. The difference is when you look at a storage system and the CNCF in the storage working group, we've written this white paper that kind of describes all of the different attributes of a storage system. You can define. It's really important to look at the attributes of your application. What does your application need in terms of perhaps deterministic performance or durability or consistency or latency requirements, for example, or scalability. BGFS is great for those really large data use cases because it is a distributed file system. StorageOS is really great for deterministic performance workloads like databases and message buses, for example.
So, Alex, as you know, you have StorageOS. Integrates. Since it's a container, it integrates with other container orchestras like Docker or Swarm and
Sure.
Mesos, I think too, right? In terms of your user base, do you see most people using it in Kubernetes, or can you run it outside of any container orchestra, like in a totally standalone thing on its own, or?
You can technically run it as a standalone container, but we really wouldn't recommend that. And the thing is this: once you use Kubernetes and you have all of the benefits of an operator to facilitate both deployments and upgrades and things like that, you never choose to live without it, right? Because the thing is, in an orchestrated environment is more dynamic and more agile by definition, right? You pick orchestration because you want your cluster to scale, nodes come and go, nodes get upgraded, perhaps you want to do work across availability zones, all of these sorts of things. To do that by hand is obviously technically possible, but you wouldn't need, it wouldn't make sense to do it without Kubernetes. So I'd say the vast majority of StorageOS users are Kubernetes users. Yeah. Anything else?
Sorry about it, but we have to wrap it up here.
That's cool. Thanks, everyone.